Yes, once again, good evening to all of you. I welcome you all to another session of our control system subject concepts. Today, I am going to explain you one more example which is asked in UPSC's Indian Engineering Service examination from this control system subject, and on the topic of finding the transfer function for the given block diagram and by representing that block diagram in signal flow graph. That means that in today's presentation, I am going to solve one example, which is not example, it is a question asked in UPSC's examination. The block diagram problem was given and you are asking to draw the signal flow graph diagram for that given block diagram. The block diagram should be converted into signal flow graph, and for that signal flow graph you need to find out the transfer function. Normally in your academic examinations also you will be asked such type of questions. That's why I already in my earlier presentations of signal flow graph methods, I have already explained to you that the very beauty of this signal flow graph method is that for any given block diagram, you can represent the given block diagram into signal flow graph. You can convert that block diagram into signal flow graph, thereby by applying the 4 steps which we have seen in earlier sessions. By applying these 4 steps, you can easily find out the given transfer function. Sometimes in academic examinations, you may be asked some bigger problem of having multiple more number of blocks, like means G1, G2, G3, G4 and so on, or more number of feedback loops also, and more number of summing points will be given, or you may feel some kind of confusion in block diagram reduction. Therefore, suppose if you are not aware and if you do not have the proper practice and if you do not remember the formulas which we have seen in block diagram reduction, means there are certain rules we have seen. If you forget those rules, definitely there is a possibility of committing doing mistakes. Then obviously you will get some wrong answer. That's why I am remembering you that please practice, please listen carefully. If you listen very carefully to my presentations, and you definitely will remember till ever and forever. I assure you that. Okay, that's why please concentrate, please follow the steps and the way how I am presenting. You definitely will understand. Okay, you will never forget that. Okay, if at all, definitely there is nothing wrong to practice more and more. There is a saying, okay, the practice makes man perfect. That's why practice is very much required. Practice is very much required. Is it not? So, in today's lecture, it is our lecture number 13 we see. It is lecture number 13. By the way, it is lecture number 13, in which I am going to solve one question that is asked in UPSC's IES in 2010. It is asked Union Public Service Commission. Union Public Service Commission, normally the IES is nothing but Indian Engineering Services Examinations, that is to be conducted by this commission, that is Union Public Service Commission. It is a central government body. Every year it will conduct the IAS examination. This is exclusively for 4 branches, and in definitely I will brief you on one particular presentation. I definitely will cover IAS, the pattern, and who conducts the IAS, and the pattern, and the gate regarding the gate also. And one day in one presentation, or in one or two presentations, I will definitely will give you the information about this also. It will be very useful for you, and at that time we will see about that. But now today in this class, in this presentation, we would like to solve one question. So here the question is that there is a block diagram given. Basically there is a block diagram given. So for the given block diagram, let us okay, so this is like this. This is R of S. Basically you have summer point followed by another summer point followed by gain G1 followed by summer followed by G2 followed by G3 followed by summer and then your C of S. C of S, and then this is your R of S. Okay, this is the flow. This is obviously inputs are always plus. Okay, this is one thing they have given, and then you have, after the summing point, you have one node. Basically from this first summer you have with negative feedback, and from this there is a unity feedback. There is a unity feedback loop is given. Okay, that is given like that. And before G2 there is a summer. Here you have given with the negative feedback your H2 is given with the same. From this point it is connected to here. It is given like this in the question. It is H2 going to the negative feedback, and then after G2 to the next summer. After G2 there is a point here, like this. You can draw like this, you can bypass. There is H1, basically this is your H1 going to the negative feedback, and this connection is coming to here, means this is going to here after G2. Okay, that is feedback loop basically. And then before G1, from this point, from this before G1, it is going to the summer, the final summer, means here. From here it is going to, as it is G4, and it is going to connect your this summer. It is going to plus. It is going to plus. Therefore Now the question is completed already now. This is the question given. This is the question given. It is asked for 10 marks. It is asked for 10 marks. It is asked for 10 marks because in IAS examination there is a descriptive type also there. Descriptive type questions will also be there, in which you are normally asked descriptive type. Okay, so now this is the given block diagram. For this you need to, you are asking that what is the question, draw the signal flow graph. The question is this: draw the signal flow graph. Draw the signal flow graph and find C of S by R of S. That is your question. Draw the signal flow graph for the given block diagram, and then you are asking find out C of S by to the R of S. That is your question. Now let us see the solution. Let us see the solution. I will keep the problem as it is for your better understanding, and okay, now we will see the solution for this problem. First of all, let us draw the signal flow graph for this. Okay, let us draw the signal flow graph. So I write the solution for you. Now I am solving this. Carefully listen. Definitely you will understood. You will enjoy this. For any given block diagram problem, in order to convert the given block diagram into the equivalent signal flow graph, you need to consider all the summing points as well as the takeoff points and the input and output as nodes. Understood? You must consider the input as a node, and you must consider the output C of S is also another node, and not only input and output, all the summing points. You see, this is a summing point, this is a summing point, this is the another summing point, this is the another summing point. Means 1, 2, 3, 4. 4 summing points are there. Means all these summing points you have to consider them as node points. Means these will be represented as nodes in signal flow graph, including your R of S also. R of S also you have to consider as node. This you have to consider as node, and you need to consider this summing point as a node. This summing point also, and this summing point also. Not only that, other than summing point, you have takeoff points also. Let us see, after this summing point, before this G1, there is a connection you are able to see here. There is a connection through which your G4 is connected to summer. Means this point is called your takeoff point. Clear? Remember, no? From beginning, I am explaining the same to you all. So this is called takeoff point. And is there any, this is also called your another takeoff point, and this is also called your another takeoff point. However, understood? So this is one takeoff point, this is the another takeoff point, this is the another takeoff point. Okay, this is also takeoff point, this point is also takeoff point, this point is also takeoff point. But here remember that this point is nothing but this is also taken from this point only. Therefore, these two are on the same line. Therefore, not necessarily to be considered this as a separate node, because instead of these two, you consider one point as a nodal point. node point. That's all. Not required to consider this as separate, because these two are on the same line. These two are there available. These two are available on the same line basically. Therefore, instead of 2, you consider as 1. So, means that what? Now I am drawing the signal flow graph. Okay, understood now? Therefore, input and output as well as summing points and then as well as your takeoff points must be considered as nodes. First of all, remember that. Okay, then now count how many. Then immediately in the given signal, in the given block diagram, what I suggest you that you just identify like this, then you will feel very easy and you will not confuse of identifying the nodes. You will, okay, there is no chance of doing mistake if you do like that. How? Just give number 1 here, means that is node 1, is it not? Next summing point, give number 2, that is node 2, 3, and this is takeoff point 4. After 4 it is a point, means 5, because na, so between 4 and then 5 this block is there, G1. Don't consider block as a node point. No, G stands for, it represents the gain. G1 represents the gain which is available for the path, which is okay, which is the gain of the path which is there between 4 to 5. So between 4 and 5 there is a path. For that path, G1 is the available gain for that path. Understood? Therefore, G1, G2, G3, these are the gains. Okay, so gains are gains only, not to be considered as nodes. Don't confuse at all. Therefore, you, okay, so between 4 to 5 this is gain. Therefore, this is the 5, and then after that this is the takeoff point. Consider it as 6, node 6, and this summer point as 7, and this takeoff point 8, and finally your C of S as 9. Therefore, all these are nothing but what? This numbering stands for nodes. Therefore, how many nodes are there? Not required to consider this. I already told you that. So instead of these 2, consider as 1 only, that I am identifying as 8 only, and finally C of is also I am considering as a node. Therefore, that is the 9th node. So how many nodes are there basically? So there are 1, 2, 3, 4, 5, 6, 7, 8, and finally 9. There are 9 nodes. Therefore, now you just represent like this. You just represent like this. This is 1, 2, 3, 4, 5, 6. Okay. Is it sufficient, or otherwise I can draw a little bit nearer so that the space of the board can be utilized. Again, it is 1, let us say 2, let us say 3, 4, 5, 6, 7, 8, 9, let us say. Understood? So again, just I am drawing the signal flow graph. I am drawing the equivalent signal flow graph of this block diagram here. So just it is 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 9th node. What is your one? Just remember that this is nothing but your R of S. The first one is your R of S, and the 9th one is your C of S. Is it not? So follow carefully. Then see this diagram, see this block diagram between node 1 to node 2. This summing point is nothing but node 2. Now, while talking about the signal flow graph, here I don't talk about summing points and then takeoff points. All I will consider in terms of nodes only. Okay. Therefore, between 1 and 2, what is the path actually? There is a simple straight line. It is given a straight line. Just you draw as it is. Like, just draw, and arrow mark is there, no? Just you put the arrow mark here. Here in between, in the middle of the path, indicates that there is the it indicates it is going in the forward direction, it is going into the forward direction. Then what is the gain? What is the gain? What is the gain of the path? Definitely there must be some amount of gain will be there for that path. If nothing is given, like here G1, G2, G3 is given, no? G4 like that. If nothing is given here, it is given simple straight line, you must treat it as 1 itself. The gain is 1. If nothing is given, consider it as 1. The gain of that path is 1. You must consider it as 1. Right. Then again coming 2 to 3 means 2 to 3. What is there? Again there is a straight line. 2 to 3. Just draw again line. Draw, indicate the forward path in the forward direction because it is going forward direction. That's why. So you represent the arrow mark in the forward direction. So what is the gain available? Nothing is there. Simple line. Therefore again you write 1 only. The gain of that path is 1. Okay, very good. Then 3 to 4. This is 3, 4 is the takeoff point. Between these two there is a line again. Only line means that what? It is a line. Therefore draw a line, indicate forward and then 1. Means the gain is 1 again. Following? Then 4 and then 5. Between 4 to 5, what is there actually? It is arrow mark is forward direction. 4 to 5. You have arrow mark is forward direction. This is forward direction. Gain is G1. This gain, that is G1. Okay, that is the gain available between 4 to 5. Next, 5 to 6. What is direction is forward? 5 to 6 direction is forward, and it is 5 to 6 it is G2. Gain is G2. Between 5 and 6 gain is G2. Then 6 to 7 it is 6 and then 7. 6 to 7 what is gain? It is forward direction. First of all you identify the arrow mark and then what is the gain? It is G3. Gain is G3. Then 7 to 8. This is the 7. 8 is the takeoff point. Between just line is there. Nothing. No confusion at all. Just 1 only. And then between 8 and 9 only line going to forward direction and gain is 1. See how easy it is? Very easy, no? Therefore this is, we have finished one path. Now coming to the loops, there are loops, no? So here for the point 2, arrow mark is coming. From where it is coming actually? It is coming from 8. 8 to 2. It is coming with negative sign. Anything is there like H or G? Nothing is there. Simply line it is. It is a straight line. It is a feedback loop basically. Coming 8, reaching towards the point 2 with a negative sign. Means it is a negative feedback loop. It is also called as unity feedback loop. Unity feedback means the gain is 1. It is a simple line, no? What is the gain? It is 1. Therefore you can identify that it is 2. So it is 2. In point number 2, it is show the arrow mark. From 8 onwards, just to draw a loop. Likewise, just indicate 1 means -1 you write. 1 is the gain of the path. Going to the minus sign means minus into 1 minus 1. That is the gain of that path. -1. Okay, that is what the gain you have to represent like that. And similarly again from 8, this means that this connection is also from 8 only. Remember that this is nothing but this connection is actually coming from 8 only. Therefore from 8 you can show H2 2.5, I mean 5. Node 5 means 8 to 5 means 8 means, so this is 8 and then 5. You have one loop here basically. What is that? What is this loop? That is minus H2. It is H2 basically. It is coming H2 with negative sign. Therefore you have minus H2. Understood? And similarly from 6 to 3. So 6 to 3 means 6 2, 3, you have what you will have? Minus H1. It is minus H1. 6 to 6 to 3. What is the feedback gain? It is H1, and this H1 is going to the negative sign. So negative is multiplied by this H1, therefore minus H1. So the same. Okay, so these are the loops. These loops I have finished. Then what else is there? From point 4 to point 8, there is a G4 going to the forward direction. Means we can draw from 4, this is 4, 4 to 7 actually. Means 4 to 7 you draw like this, going forward direction. What is, it is going to the forward, therefore forward direction. G4 is the gain. Understood? G4 is the gain. Is there anything left here? Nothing. We have successfully represented the equivalent signal flow graph for the given block diagram. This is the signal flow graph. Understood? Any doubt in this? Therefore, remember these points very carefully. So each input, output, summing points, takeoff points must be considered as node points. Identify the nodes in the block diagram itself, and then the same nodes, how many nodes you have to count, and those nodes you have to represent like this, 1, 2, 3, 4, 5 like that, and you just draw the path with their path gains either in the forward direction or reverse direction by carefully carefully observing the block diagram. In the same path you have to identify here, but in the form of arrow marks only. Then this is called the signal flow graph. This is called the equivalent signal flow graph of this block diagram. Now one step is over. In our solution part, the first step is draw the signal flow graph. Now this is the signal flow graph. Now coming to the next step. Now I will erase these things, and now we will solve this signal flow graph using our steps which we have seen in our previous sessions by applying the steps. So there are 4 steps normally we have seen. So very simple, very simple. So step in solution, according to the step 1, what is step 1 for the signal flow graph? After completion, upon the completion of the signal flow graph representation for the given block diagram, then immediately you need to apply steps. Okay, what is the first step actually? It is the number of forward path, not required to mention all the times, means we know already. So in step 1 we have to identify the number of forward paths with their path gains. So directly I will write, what is the first one? Number of forward paths, is it not? Number of, otherwise just for your sake one time I will write number of forward paths with their path gains, So number of forward paths. How many forward paths are there? Forward paths, I already explained. Forward path is nothing but that is the path starting from the input RFS and reaching towards CFS in only one direction. In only one direction means in forward direction only. It has to go in forward direction, and it should not return, and it should not touch any other node twice. It should touch the particular node which are there on that path, must be one time only the path has to be touched. So if you apply that step to this, then from RFS to CFS, see that the straight line, actually this straight line is nothing but your first forward path, means the arrow mark is going to forward direction here from RFS, and then from 1 to 9 nodes. Then what are the gains? All these are the gains. 1 into, this is also 1 into J1 into G2 into G3 into 1 into 1. That is what your first forward path. It is P1 is equal to, just multiply all the gains. Obviously we will have G1 G2, G3, that's all. Because into 1 into 1 into 1. 1 is nothing but 1 only. This is your first forward path with path gain this much. What is the second path? What is the second path? Second path, there is another path. That is what the second forward path that starts from R of S, and it starts from here going to forward direction, going to forward up to 3 and up to 4 also, and from here it is going to G4 direction. Like this it is going, it is taking some diversion here. From here coming up to 4 it is coming straight with gain 1 1 1. From 4 it is going to G4, and from here it is rating to G of S. Means what is the path gain? 1 into 1 into 1 into G4 into 1 into 1. What is the gain? It is G4 only. That is your second forward path. That is second forward path. Other than forward path 2, I mean other than these two, is there any forward path available in this? See carefully. This arrow mark is forward. This is already finished. This is also finished. What else is remaining? These are the remaining path. Let us carefully see. On this path, the arrow mark is showing reverse direction. If it is reverse direction, you should not consider it as a forward path. That is very clear. Therefore, other than these two, there are no any other forward paths available for the signal flow graph for this problem. These are the two gains, forward path gains we have under this step number 1. Next, come to the step number 2. What is the step number 2? Number of individual loops. Is it not? Number of individual loops with loop gains. What? With loop gains. Nothing but L1, L2, L3 like that. Is there any loops? Yes, definitely. Let us see from the beginning or whatever, in whatever way you want to consider. See the bigger one, actually if you see this one minus 1. So here it is going like this, straight forward it is going to like this and reaching to this node and coming back actually with minus 1. Therefore, you can consider it as a loop. Understood? Understood? Means that, let us see, from this node, from the second node, actually it is the second node, from this node, the path is going forward direction, again forward, 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 up to node 8. From node 8, you have feedback loop with feedback gain 1, minus 1. Therefore, that is what your loop 1. That is what your loop 1. So, all the gains means 1 into 1, start from 2 only. Don't go back. Don't confuse. So, what is a loop, by the way? Loop is nothing but that is the path should start at a particular node and finally it should end, it should reach to the same node. It should terminate at the same node. It should start and it should end at the same node. That is the loop. Means that it started from here going up to 8, coming back actually means 1 into 1 means what you have G1, G2, G3 and with minus 1. So minus 1 is multiplied, therefore you have minus G1, G2, G3. That's all. 1 into 1 into G1, G2, G3 and it is coming minus 1 means minus will come, no? G1, G2, G3 minus. That is your first loop. Next, that is completed. What is other loop? You see, the next one coming to the here. So, if you start here from third node, it is going forward direction, forward up to 6. You consider up to 6, and again from 6 it is coming to back and finishing to, it is reaching to 3 itself. Means this path is going forward direction up to 6 and from 6 it is coming back. Therefore, what are the loop? Then consider that as loop 2. So, what is the path gain for this? 1 into G1 into G2 into H1. A minus symbol is there. Therefore, G1, G2, H1. What is that? G1, G2, H1. But the sign minus is there. Therefore, you will have minus sign here also. You will have minus also. So, that is your second loop. This one from third node going up to 6, coming back to third. That is your loop 2. Then, is there any? Yes, you have one more also. loop 3. What is loop 3 here? Now start from node 5. Let us consider here. Let us consider node 5. So from node 5, if you start, the arrow mark is going forward direction up to 7 and then up to 8. From 8 it is coming back and reaching to your node 5. Means, understood? From 5 to 8, 8 to again 5 means what are the gain available on that path? G1, G2, G2, G3 and H2. G2, G2, G3, G2, G3, H2 with sign minus. That is one path. That is one path, one closed loop. That is one closed loop. What else are there? What else are there? See? So, if you see, so from here, from 2, again come here. From 2, it is going forward direction and again it is going to J4, going to 8 and coming to 1, reaching to 2. Okay, from 2 you start to, for the L4 I am explaining you. For L4 there is one more loop is also available in this. That's what I am explaining you. If you start from the node 2, from node 2 it is going forward direction up to 4 and from 4 to take in this direction J4 and from J4 going up to 8 and it is coming back with -1 to 2 reaching 2. Means this is also one loop. Means what actually? Means 1 into J4 into 1 into 1 into 1 and into -1 means you have minus J4 minus G4. That is what your L4. That is what your individual loop. And one more loop is also there. Let us carefully see. Let us carefully see. If you start from 3, let us see. If you start from 3, going to the forward direction, up to 6. Okay? Is it not? What is that? See carefully. From 3, it is going to 4, 4 to G4 and then 8. From 8, you come to 5, go to 6, reaching to 3. See, it is something little bit, I mean, you may feel, but listen carefully. Start from 3, going in this direction, going forward direction, going up to 8. From 8 you will come this, going forward, going like this, reaching to this. That is what loop, no? This is what loop. In all this path, the path is not touching any node twice. Therefore, this is another path. Means we started 3, we started at 3, going forward, going, finally reaching to 3. Means what are the gains available here? 1 into G4 into 1. This is minus H2, G2 minus H1. So minus H2 minus H1 are coming on this path. Therefore minus H1 minus H2 matlab minus into minus it is plus H1 into H2. So means that it is G4, nothing but your L5. Your L5 is equal to G4, is it not? Because you are starting from 3, it is 1 into G4 actually. It is G4, no? 1 into G4 is G4. G4 into 1 G4. Okay, G4 into this one H2. G4 into H2, and from here to G2, again G2 will come. Sorry, G2, from G2 again it comes to multiply with H1, means it is H1, and finally it is reaching to this point 3. Means on this particular path you have minus H2, these two are minus actually, minus H2 minus H1, therefore minus into minus plus, therefore you have plus here. So these are the 5 paths you have actually. You have 5 paths actually in this. Next, So other than these 5, there are no individual loops are available in this path, in this signal flow graph. Next, that is what your step number 2. Now, so step number 3. So I am erasing this. Okay, I am erasing. So carefully note down this and follow otherwise. Now, we have seen step number 1 and step number 2. This is step number 3. What is step number 3? Normally the step number 3 describes about what? Number of 2 non-touching loops. 2 non-touching loops and 3 non-touching loops. Non-touching loops which are available in the given signal flow graph. 2 non-touching loops. See how many loops are there basically? There are 5 loops are available in the signal flow graph. 5 loops. Here all these 5 loops are touching to each other. All 5 loops are touching to each other. Therefore, there are no separate non-touching loops. There are no individual loops. So L1, L2, I mean without touching. No, there is no possible combinations of either 2 non-touching or 3 non-touching. Therefore, for this step, you can write that there are, because all loops you can, the first loop, this is what the first we consider, this is the second we consider, this is the third we consider, and this is the fourth we consider, and this is the 5, which is when I indicated with this one, blue one. This is the fifth one basically. All are touching to each other. Therefore, you can say, you can write that there are no, what you can write? There are no two non-touching loops and 3 non-touching loops available for the given signal flow graph. There are no 2 non-touching and 3 non-touching loops are available in the signal flow graph. Therefore, your step 3 is not at all applicable to the signal flow graph. Simple. Now, coming to the last step and final step, that is step number 4. What is step number 4? So, that is what your transfer function formula, that is called as Mason's gain formula. What is Mason's? Mason's gain formula. This is called Mason's gain formula. What is that? As per that, your transfer function is equal to C of S, means output by input R of S, is equal to 1 by delta sigma, it is K, is equal to 1 small n Pk delta K. This is the formula. Always remember. Is it not? This is what Mason's gain formula. According to Mason's gain formula, C of S by R of S is equal to 1 by delta sigma K is equal to 1 to n Pk delta K, where Pk means, what is the K? K is equal to number of forward paths, where K is equal to number of forward paths. Number of forward paths available for the given signal flow graph. So, as far as our problem is concerned, how many forward paths are there? There are 2 paths we have seen, P1 and P2. Means that what is your K? K is equal to 2. Okay, then substitute that value there. So, this I can erase now. I think this is not at all required now, because we already taken the information from this graph already. Therefore, I will erase that now because I need to simplify. Therefore, it is transfer function is equal to C of S by R of S is equal to, if I expand K is equal to 1 to 2, then your transfer function becomes 1 by delta of, it is P1 delta 1 plus P2 delta 2. Is it not? If we expand this summation, this sigma, you will have like this: P1 delta 1 plus P2 delta 2. This implies, what is P1? Your first forward path. What is delta 1? Delta 1 is nothing but, consider the path 1, means first forward path 1. With respect to the first forward path, is there or any non-touching loops are available in this given signal flow graph? If it is available, then you have to find out the value of that path, individual loop gain. So that as delta is equal to 1 minus loop gain is the formula. If it is so, because for this given problem, all the loops, 5 loops, we have individual loops, all those 5 loops are touching to the first forward path. Therefore, in this case, your delta becomes 1. Your delta becomes 1 because there are no non-touching loops. All loops are touching the first forward path. Therefore, your delta 1 becomes 1. Similarly, what is delta 2? Delta 2 is nothing but, consider forward path 2. For the forward path 2, is there any individual loop which are available in the given signal flow graph and which should not touch to that forward path 2? Is it so? If it is there, then we have to find out the value of delta. That value of delta is nothing but delta 2. But as far as our problem is concerned, again if you take the second forward path, all your loops, what are the loops available in this? All these 5 loops are touching to that path also. If they are touching, there is no question, there is no doubt at all, consider delta 2 value as 1. That's all. That's all. That's all. Therefore, finally what we will have means it is 1 by delta is equal to P1 plus P2. That's all. P1 plus P2 by delta. What is delta? What is P1 you know, P2 is also know. What is delta actually? What is this delta? Delta is equal to 1 minus sum of loop gains, means your L1 plus L2 plus L3 plus L4 plus L5. Is it not? Plus L5. That's all. It is minus. Next plus will come basically. Plus, if two possible combinations, non-touching loops, if that combination is there, then you will have some value. 3 yes, you don't have 2 non-touching, 3 non-touching. So therefore, these delta will finishes here itself. There is no further component will come here. This much only. 1 minus L1 plus L2 plus L3 plus L4 and L5. That is what your delta. Therefore, finally, I'll write the final answer, means by substituting all these values in this formula, Mawson's gain formula, finally you have your transfer function is equal to your C of S by R of S is equal to P1 plus P2. No? What is your P1? P1 is nothing but your G1, G2, G3. What is P2? Nothing but your G4 only. Put in a bracket. Then what is delta value? Delta value is nothing but 1 minus what is L1? It is minus G1, G2, G3. What is L2? Minus G1, G2, H1. That is our L2. What is L3? Minus G2, G3 minus G2, G3, H2. Is it not? H2. That is what your L3. What is L4? L4 is nothing but your minus G4. What is your L5? It is plus basically, because H1, H2 will come. This is G4, H2 and G2, H1. This is what your L1, L2, L3, L4, L5. And finally, if you simplify this, it is G1, G2, G3 and then G4 by, it is 1. So, it is minus of minus. Therefore, it will be plus G1, G2, G3 minus into minus plus again here. Therefore, you will have G1, G2, H1, is it not? Then again minus of minus plus G2, G3, H2, and again here minus of minus plus means plus G4 you have, and here plus minus into plus it is minus G4, H2, G2, H1. This is what your transfer function of the signal flow graph. This is what your final answer. Understood? Likewise, this is your final answer. This is your final answer. Therefore, likewise, you need to solve. You have to apply this thing and you have to solve the question, right? I think you enjoyed, you understood. I hope that you are enjoying the class and you are following. Okay, I expect the comments and suggestions, feedbacks from you all, because so that it will improve you only by giving feedback to me, so that I will improve and for your betterment. Okay, so with this today's session I am going to conclude at this, and in the next subsequent sessions we will see some more important questions. Normally they have asked from our GATE examination as well as UPSC IAS examinations, and let us see. Okay, therefore with this today's topic will be completed, and don't forget, dear friends, to comment and to give your suggestions, as well as don't forget to share your valuable friends. Therefore it must reach to the maximum number of students community, because I took the privilege of giving and sharing my knowledge, so that it must reach to every average and below average or any kind of students. You must excel. You must excel, and you must excel in your career, must reach to higher and higher position. Okay, thank you one and all.